by hand. By unscrewing this, that is screwing it counterclockwise, you can watch your regulator, and it's going to show you that your pressure is dropping as you do this. I'm screwed all the way in, so it's going to take a little bit. Okay. Now you hear it starting to drop. And now I can see that I'm at 60 psi, 50 psi, 40. And if you need to lock it at a certain place, you just press this down, and most of these have this little kind of castle lock in it to keep it locked. Now the purpose of this is the drill is still spinning. Air is still coming out of the back end of it, but it is not actually running very fast, which means if you give it any significant reason to stop, like pushing it into the mud on the bottom of the well or the wall or whatever, it's likely to slow down and stop. But the air will keep running, and that will be very important later. But under almost all circumstances, you're going to want this thing to be regulated all the way up and get as much air into that drill as you can. So that's basically how the oiler operates. Again, keep an eye on it. Watch the level here. When it starts getting low, you can, if you have to drill a little bit longer for some reason, you can tighten it down so it comes out a little bit slower. But it's best not to run it too slow, because again, you need to keep that oiled in there. So when it starts getting low, plan that you're going to be pulling the well soon. And when you pull it out, make sure you put oil in it. Every time you pull the well out, no matter how short a time you've been in there, top off the oil so that you can drill for as long as possible. They make these in various sizes, some are really small, some are really big. You can get them at Harbor Freight Tools, Northern Tools, various other places like that. You can buy better quality ones from Canberra Housefield, or you can find a lot of places. Just look for Aero Lubricator and go for one that will work for you in your budget. The lower quality ones are going to break more often. That's just how it works. Now, one of the cardinal rules of well drilling, in fact, the number one rule of well drilling, is that under no circumstances are you ever to have the drill turned off underwater. The reason being is that the drill is under pressure. You're underwater, which means that that pressure is holding back the water, so that as it spins, the air comes out the back and pumps. Right, that's the idea. But the point is that if you turn off that air, then all that water and the mud gets sucked inside the drill in half a second. It takes no time at all. You have a pressure, and suddenly you have a vacuum. That means that your drill is full of mud. Drills don't turn well when they're full of mud. It's something not everyone realizes, but it's true. What that means is that you must never lose air pressure while you're underwater. If it happens, you will have to take your drill apart from the scratch, which we cover later in the video because people don't always follow instructions and sometimes accidents happen. If it happens, you'll have to take it all the way apart, clean all the sand out of it, and it's a very laborious task. It'll take a better part of a day. You can avoid it by never turning the drill off underwater. And I'm going to repeat this a whole bunch of times just so that you can make sure that you get this because this is very important. So when you turn the drill on, it's going to be turned on before you put it down in the water. When you turn the drill off, it's going to be after you get it out of the water. This is the number one rule. There's several rules. This is by far the most important. What this means is that you need to be very sure that your air supply is constant. So you need to make sure that if you're using a gas compressor, it has plenty of gas, because if your compressor runs out of gas while you're underwater, yes, you'll lose pressure and you'll fill up your drill with mud. Long before you can get the drill out of the water, it's going to be full of mud. So you need to be very sure that there are no bad spots in your air hose, no joints that are weak that are going to pop apart under pressure, like bad fittings and so on. This stuff is obvious, but it's important. Double check it all. What's most important of all is that you have no quick connects on your well. Under no circumstances are you to use these. Not on the compressor, not in the line, not before the oiler, not anywhere. Because these are very easy to take apart. That's the idea. So you put this together like this, a little bit of pressure, pop, they're off. So if this is laying on the ground and somebody walks over it and bumps it with their foot, this thing pops apart. If this is powering your well at the time, that means that your drill loses pressure, and again, you have to go back and clean your drill out. This is not fun, you won't like doing it, so you can avoid it by making sure that there are no quick connects, no problems with the air hose, you have plenty of fuel in your compressor, all these basic things, as well as making sure that everyone understands that you are not to turn the drill off underwater, ever, for any reason. That said, things do happen, people do ignore directions, things do break, air hoses do explode, compressors die, people drive over the hose and the oiler and everything like that. I've had this stuff happen to me. All this stuff happens, and if it does, you can fix it most of the time. But that will be covered in a later part of the video. Meanwhile, you can avoid most of that just with some common sense up front and double checking everything right now. So we basically got the entire well area set up. We haven't done the compressor yet. I'm going to show you that here in a minute. But we've prepped the well area. We've got the hole drilled. We've got the pipe running to it, the screen on it, the pit dug, the barrel to catch the water in. The drill's all connected. We've tested it so it works. Everything is good so far. Now, this pipe that I'm holding right here is a short piece of 1-inch pipe with an elbow on the end of it. Now, this is not glued together, and it doesn't really need to be. What's going to happen is, as you drill, this pipe is going to go down vertical, and it's going to arc back up and come back down like this. So for a while, you have 25 feet of pipe here, That's going to come over here and spray the mud right in this pond, which is great. However, as you get deeper down the well, the pipe that's out of the ground gets shorter. And that means instead of being over there where it's out of your way, it starts pointing up like this or like this. And that obviously, well, not to say obviously, but anyway, it sprays mud over everything and everyone, which is not necessarily a good thing. Depends on who you are, I guess. Anyway, this pipe, when you get shorter, can be tapped onto the end, and it will hold on there and allow you to direct where it goes. You can aim it at whoever you don't like. And I don't recommend that, but you know what I mean. Anyway, this will let you keep the mud out of your face, out of everyone's hair, and point it in a safe area. So we're going to set this aside. We don't need it yet, but when we do, it's going to be handy. And that's one of the biggest keys of success, is have everything done before you even start drilling. Have all your casing done, have all your tools together in one place, have all your pipe here, everything ready. That way you don't have to stop drilling to go do something, to go buy something or find something. If everything is set up before you ever start, if you're renting a compressor, get it all done before you even rent the compressor. That we have the most time for the most value you can get. So another thing you need to set up before you start drilling is a water supply. Now obviously you're drilling a well to get water, and so you may not have water while you're drilling. But you can haul it in buckets or barrels, things like that. You're going to take a fair amount of water, but probably not as much as you would think you need. A couple 100 gallons a day might be enough, depending on what you're drilling in. You must have water in the hole at all times while drilling. What happens is, this bit stirs up dirt. Now the water helps to lubricate that process, makes the bit last longer, and helps it to dig it up easier. But also, the water is used to extract the dirt by sucking it up into these holes and blowing it out the top. So you have to have that liquid enough so that it can work around and come up here. Otherwise, you're going to have this goopy mess trying to suck these holes, and it won't work. So the thinner the water is, the thinner the mud is down there, the better you're going to pump and the easier you're going to drill, and therefore the faster you're going to drill. But also, the whole pumping action itself is dependent upon having water above the drill. What basically happens is, this is standing under, say, 20 feet of water. Air is coming out of here, blowing up the pipe. Now, the pressure of the water around there is pretty significant, and pushes down and pushes into those holes, and then the air pressure blows out the top. It'll do the same with the mud. The thicker the mud is, the worse that works. The more water you have, however, the more pressure there is, and the better that works. So having it full of water at all times is going to go a long way towards making your pumping efficient, towards getting tailings out of the bottom, and all around it's a better thing. There's also a third reason why you have to have the water running in the well at all times. And that is that when you drill a hole in the ground, obviously the tendency of the ground around it is to collapse and fill in that hole, because there's a vacuum there. You have nothingness here, a whole bunch of dirt around here pushing down on it, so it's natural for the dirt to fall in. If you fill that hole with water, then it's not empty anymore. Now, it's not as heavy as the dirt was, but it's something, and it helps to push back the dirt a little bit. We're going to discuss drilling mud later, but drilling mud will also help with this process, so we'll come back to that then. For right now, what you need to know is that you need to have a water hose. If you have city water handy, you can drill with that, or barrels or something like that handy that you can pour in the well to keep water in the hole. Now, I've got 3 tanks around here, 500-gallon tanks that I've got full of water that I'm going to use to run in here. So I'm actually drilling off-grid, so you can too. After the drill itself, the most important thing you need to get a hold of is a large compressor. Now, the drill is powered by compressed air, and so you need a large compressor, and the larger compressor, the better the drill is going to run up to a certain point. Now, there's a basic minimum amount of air required to turn the drill, and then more importantly, there's a basic minimum required amount of air to keep up with the drill once it's turning. Now, these two measurements are PSI and CFM. PSI is the pressure that the compressor puts out. The CFM is the volume of the air that the compressor can put out at that pressure. So here you have 14 CFM, or SCFM, it's basically the same thing, at 100 PSI. And that's how much volume of air it can put out at that pressure. Now, this compressor is actually too small to run our drill. This is a big compressor, but it's actually on the low end of the ones of this size. The drill requires a lot of air to run. It's difficult to tell you exactly how much air, because each compressor rates their CFMs a little differently. And once they start running, they change a little bit, and they probably scam the numbers a little bit in the factory. Anyway, I've heard of this happening quite a bit. So I've seen compressors that were 16 CFM that could drill a well just fine. I've seen compressors that were 20 CFM that wouldn't drill a well. And so it's kind of one of those things that you're going to have to find out with your own compressor unless you have plenty of air where it doesn't matter. So one way that you can get a general idea is you need to see the horsepower of the motor, because the motor is what drives the belt which turns the compressor. A larger motor theoretically will create more air. Not always true, but it's a good place to start. This compressor is rated at 14 CFM at 100 PSI and has a 6 horsepower motor. Now, that's probably pretty accurate. But if you see a 6 horsepower motor on a machine that's rated at, say, 20 CFM, That's probably not accurate. They're probably trying to make you think it's more powerful than it really is. When you actually plug it into your drill, you're going to find it's not putting out as much as you're wanting it to put out. So one way you can tell is just to look at the horsepower. You want something that's got 7.5 to 8 horsepower minimum. More than that is better. A two-stage compressor is a lot better than a single-stage compressor. That has to do with how it pumps, whether it pumps on both strokes or just on the one stroke. And it'll put out a lot more air with a two-stage, but those are also a lot more expensive. So you want as good a compressor as you can get, but if you have one that's close to the edge, like this, I can slave it together with another compressor here, which is an 8 CFM, and I can tie these two together, and together they produce enough air. Now, you would think that an 8 CFM compressor plus a 16 CFM compressor would equal 24 CFM. Unfortunately, it doesn't really work that way because, again, the numbers don't add up right, and you're probably more realistically going to get closer to 20 CFM or 22 CFM if you're lucky out of that. But that's still plenty to drill the well. I've drilled several wells with this setup right here. So if you have people you can borrow compressors from, you can put together 3 or 4 smaller compressors. I know one guy who did up to 5. I don't really recommend that because it increases the probability that one of them is going to have something go wrong, or one of your connections is going to explode, or something is going to just be funky. But it is possible to do it that way. It's much better if you have one good compressor and just go straight with that. So you can rent a compressor, one of these big trailer-mounted rigs, and they'll put out 125 or 185 CFM or whatever, which is way more than you need. Now that won't hurt your drill any because more pressure is not really going to hurt it, but it will just basically sit there and idle and suck gas while you really don't need anywhere near that much pressure. So those are going to cost you between $300 and $500 a week to rent most places, and you're going to be spending maybe another $200, $300 on gas or diesel. So that means you're looking at up to $800 a week to rent a compressor, which is fine if you're only going to be drilling a well for a few days or a week. But if it winds up being a bigger deal than that, then you basically just pour $800 down the drain, and then it wants another $800 and another $800 and so on. Well drilling is inherently unpredictable. Sometimes it takes longer than others. Sometimes it takes weeks instead of days like it should. It's hard to tell. So if you have a compressor sitting there just eating up time and money because it's on your property, whether you're using it or not, that can get very frustrating very fast. So I recommend that if you can afford the overhead, just to buy a compressor, even at $2,000. Sometimes you can get them as low as $800, sometimes them like $2,000. Use it for a few weeks or months or however long you need it to do your job, and then sell it. It'll be basically brand new. You can take a couple hundred less than what you paid for it, and you're still money way ahead over what you would have had renting a compressor, and you have no stress because it's yours for as long as you want it. So that's what I recommend if you can do it. So this is the other end of that half-inch air hose you saw a few minutes ago hooked up to the oiler. I have it hooked up here through a valve so I can turn it off, and on this end is another valve so that I can hook it up to that compressor and turn that compressor off. Now, if you're going to do this, I'm not going to go into too great a detail because you shouldn't be doing this if you don't know something about what you're doing anyway. But I'm going to give you the general idea here. You need to find the place where you can take off a fitting, put a T onto it, and hook up another hose to the other compressor, like I've done here. Now, this compressor has no valve built into it. It has the pressure gauge, but it has no valve. Now, it's been drained of all pressure, so there's nothing in here right now. You always should start with that. Right now, it has a quick connect on it, which most of the time is pretty convenient. But how do we feel about quick connects? That's right, they're evil. So we take them off, like so. And I've Teflon taped this fitting. I'm going to screw it in. Now, if you must use aftermarket fittings, always back them up with other hose clamps. So rather than using just one, notice I've got 3 on here. I do not want this coming off, blowing apart, and having a big blowout over here while I'm down in the hole, which will cause me to lose pressure and therefore have to clean out my drill. So now I've tied this into that other compressor. Notice it has a valve cutting off that compressor. Since it doesn't have one down there, it needs one up here. And it has a valve here cutting off this compressor, which means technically I can run it from either compressor if I need to. So if this one runs out of gas, or if this one blows a circuit or whatever, I can still continue having air going down the hose into the drill. Now it won't be enough to run the drill properly, but it will be enough to keep air in the hole, which will be enough to keep mud out of the hole. And that's what's important here when you're drilling the well. None of this is necessary if you're only going to hook up to one compressor. Just take off the quick connect and hook it up directly into the valve and run it straight out that way, and you'll be fine. Notice, however, that I have this laying down this way, not up like this, where it could kink off. Something like that could go wrong. Try to keep it in line with the direction it's aiming. Just basic common sense stuff like that. So if you're not sure the compressor will put out enough air for you, what you can do is test it before you start drilling the well. Bring the drill over here, put it on a workbench someplace, hook up an oiler to your compressor so that you don't have it running without the oiler for any length of time. Hook the air hose up to your drill, turn it on, obviously without the bit in it, and let it run. Now your compressor is going to start out running it just great. You're going to have 120 psi in here or something like that. The drill's going to sound really great and it's going to run. But after a while, if your compressor is not able to keep up with the drill, then the pressure gauge is going to start dropping. And it'll start out at 120 or whatever, and it's going to go down to 90, 75, 50, 40, whatever. It's going to eventually find an equilibrium where the drill is using the same amount of air as this can put out volume. Now that's going to mean the drill is going to lose speed, it's going to lose power, and so on. So you want to watch your gauge, and after about 20 minutes it should have reached an equilibrium. If it's not still dropping, you'll know it's there. And usually a good compressor will keep up to about 90. That's a good speed. Below that, it may or may not work. It's kind of one of those things that I wouldn't do, but you might be able to get away with. You need a compressor that's going to keep up with 90 psi to get optimal use out of it. Now above that, the compressor will keep up with, say, 120 psi. That's great. More than that is not going to make any difference because the drill can only use so much so fast. So more psi won't hurt it any, more CFM won't hurt it any, but more is better up to that certain point of about 25 CFM and about 110 psi. That's about all the drill can really use. When it comes to casing your well, you have three basic options. The one I recommend that most people do is the 4-inch thin wall PVC pipe. I do this because it's easier to use. It's flexible and is able to, on long spans, curve and follow the hole even if it wiggles around a little bit. So you don't have to use the pipe straighteners like we use around the drill on this video. You can just go straight down without those. You can get a 100-foot well and 4-inch pipe will almost always follow it if it's thin wall. Thin wall, another name for it is Schedule 20, also called SDR 26. Basically, it has a wall thickness of about 3/16 of an inch. They use it for sewer and drain applications, for French drains, things like that. It's food grade and everything, but the only problem with it is that it's not as thick or as rigid as the others, which means that theoretically, if a rock slides over under there or you have something shift down there, it could get squashed and you might lose your pump down there. In reality, that almost never happens. And I've only heard of it happening twice in the entire time I've been doing this, and both times I'm pretty sure the person who did it wrong, if you know what I mean. So, this is what I recommend, 4-inch thin wall. One advantage of this is that it always comes with bells built into it, which means you don't have to get couplings. Because when you have a bell looks like this. It's already part of the pipe. It's already smooth here, which means when you go to push it down the well, the bell is going to bounce off the rocks or sides of the hole or whatever, and it's going to follow smoothly. Also, the thickness across this at the bell is 4.5 inches, which means that if you drill a 5.5-inch hole, then you have a full inch to play around in. When you put a bell on here, the thickness across the distance of a bell is 5.5 inches, which means that bell will not fit down your hole, which is why you always need to get ones that have bells built onto them. They'll be a little harder to find, but it's worth it. That said, not everyone can find the 4-inch thin wall. Not every state allows 4-inch thin wall casing, and some people just want a stronger well they don't have to worry about. For that, we have 4-inch thick wall. 4-inch thick wall is also called Schedule 40. It's much more common, it's available just about everywhere. The only problem with it is, it's very thick, it's very heavy. So if your hole is not really straight, it will probably not go down. It doesn't have much bend in it, even over a 20-foot stretch. So if you're going to do this, you have to have the spacer in the hole. Also, 4-inch thick wall is 5 inches across the pipe, which means it's about 5.5 across the bell, which means you need a larger hole. If you use the 6-inch deluxe rock bit, it measures 6 inches across, which means you have just enough space to clear it, but not much any extra. So it's kind of sketchy. If you're going to go deeper than 100 foot, you really need to ream it out to 8 inches, even if you're only going to go with a 4-inch casing. So that's 4-inch thick wall or Schedule 40. Now there is a pipe in between these two called SDR 35, and it's pretty common. And it's kind of a little bit more towards the thin wall than the thick wall, and most people can find it. So if you kind of want to compromise, you can go with that. Finally, we come to 6-inch. Now, 6-inch wells hold more water in the pipe. Now this is a small advantage, but not as much as you'd think. When you drill a well, you're not really drilling a well to put a piece of casing in there to hold your water. What you're doing is you're piercing a hole into the aquifer so that the water can pour in, pump the mud out, and then once you're done with that, you'll have a chamber, maybe 10 foot across down into there, that has been evacuated of all the mud, and you'll have a big chamber of water left. And that's where your water reservoir really is. It's not kept in the pipe. So while if you have a 6-inch pipe, you'll have roughly twice the amount of water in the pipe at any given time, in the grand scheme of things, you're only talking about another 30 or 40 gallons anyway. The real reservoir of water needs to be underground. So a 6-inch pipe doesn't help much with water storage. It does allow you to use slightly larger pumps, which sometimes is convenient, but most pumps in the market are designed to fit inside a 4-inch casing. You can always test it before you start drilling. Pick out your pump and see if it's going to fit inside a 4-inch casing. Call the manufacturer and ask them if it fits inside 4-inch casing. They'll know. So you need to decide this before you start, because what casing you choose is also going to affect what bit that you need, and it's going to affect how long you need to plan to spend drilling your well. Because if you're going to drill a 6-inch well, you've got to first drill the hole out to 6 inches or so, and then you got to go back in, as you saw me do in this video, and drill it out to 8 inches. Then you got to put casing in. And the same is true of Schedule 40 4-inch. With a Schedule 24 inch, then all you have to do is just drop in a 6-inch bit, drill it out, pull it out, drop your casing in, and it's done. So it's a lot simpler, and you're going to have a better odds of success. And really, you're going to have just about the same quality of well in the end. We need to make our well screen before we get the well finished, because once you're actually drilling the well, not only will you not have time, but your compressor probably can't keep up with this tool to cut the well screen as well as the well drilling at the same time. So, make all your well screen up before you get your well ready to case, otherwise you'll have a problem. This is 4-inch well screen. It's thick wall. This is what's going to go inside of our 6-inch casing we've already got done. The 6-inch casing doesn't have any splits because all it's going to do is hold back the water so we can just get down there deeper. This, however, has to have slits cut in the side of it because it needs to have water to be able to pour in. But you can't just drill holes or something, because if you drill holes, you'll have water, gravel, and sand all pouring into your well much faster than you can possibly pump it out, and you'll really be kind of like you don't have casing at all. So the goal with well screen is you need to make slits in it that are small enough to hold back the sand, but large enough, and enough of them, that they let water in. So picture this pipe standing upright in a pool of water. You need to have enough slits in there so that the water can pour into those slits and be pumped out by the pump at 10 gallons a minute or faster in order to keep up with it. That means you need a lot of slits. Now typically the way the strata works, you're going to have a layer of clay and a layer of sand with water in it and a layer of rock and a layer of clay and so on. And you need to have these slits in the place where the sand has water in it. Otherwise, you're just trying to pour water out of rock. So if you drill a 100-foot deep well, you're going to have probably 30 or 40 feet where actually water pours in, but you might only have 6. So you need to have slits at the place where the water is going to be pouring in. The thing is, you don't know where that is where you're drilling, because all you know is you've got a big hole down there full of mud. So what I usually do is go at least half of the well with slits if you're up to 100 feet, or about 25 to 50% if you're deeper than 100 feet. I know from drilling a whole bunch of wells in this area that my water table runs from about 88 feet to 196 feet. And I have a big vein of water at 88 feet, 136 feet, and another 96 feet. And there's a little bit of water here and there between that, but that's where I have a bunch of water. And I know this from drilling in the past. I've had big cave-ins at those areas, and water keeps pouring in there. So I know for a fact I have water there. So I want to have enough well screen to pass at least 2 of those water-bearing areas so that I'll be sure to have plenty of water for all I'm ever going to use. So for that purpose, I'm going to make 80 feet of well screen for a 200-foot deep well. And that's going to give me enough, depending on how deep exactly I get, to pass at least 2 of those water-bearing areas. Now, to cut the slits, you need a tool like this. More information on this will be later in the DVD or in the plans. This has a blade that's about 20 thousandths of an inch across. Now, that's about the size of most small grains of sand. So sand can still get through these slits, but the larger grains of sand won't. And that's going to form a sort of a screen. It could also form a clog, but we'll cover that later too. So for right now, we need to make a bunch of slits with this tool. I make them about 1 inch apart in rows like this, and about 4 to 6 inches long. So make your first slit about 8 inches from the end so that you're sure to clear the bell and the end the bell is going to glue onto. So you want to put your tool down here on the pipe and use the back side of the shield as a hinge so that you can just lean forward like this and make your cut. It's a lot less stress on your wrist. I usually use the printing on the pipe as a line to line up my slits so that I don't get them too crooked going down. And so I'm going to make my first slit here, and I'm just going to turn it on and just lean it forward. Okay, so I've now cut through the pipe. Now, this slit here is quite small. It's enough, but if you had to make a bunch of these, it gets really tiresome. So in order to speed up the process, I usually push it a little bit as I'm cutting, like this. And that gives me about a 4-inch long slit, really neat. And I just go up here, skip about an inch, inch and a half. Make another one. We just keep doing that all the way down here. You want as many slits as you can get in here, but you also don't want to have so many slits that you make it weak. Now this takes time, but regular well screen is pretty expensive, and this is a lot cheaper and really does about as good a job, if not better, in some cases. So every so often, this blade needs to be cooled off, because if you're just cutting in this pipe, especially the thick wall, it's going to get pretty hot. So in the middle of the pipe, I put a bucket down there. So while I'm running this, before it gets hot, I will leave it running and dump it in the bucket, like this. That's all it needs, and that'll cool it down right like that. So when doing that every so often will make your blade last a lot longer. This is not such a big deal on thin wall pipe, but on thick wall pipe you're cutting through about 3 times thicker walls, which means you're going to get a lot hotter before you get the job done. So now we just keep going, cutting our slits, and then we roll it a little bit, repeat, and keep going. So this is my first row of slits, and now I've offset the second row so that they center on the other slit and so that they spread out the weight. That way they'll make it a lot stronger in the long run. And I'm just going to keep going until I get all the way back around the other side. So as you can see by the fact that grass has grown in some of the places that we were working last time, it's been about a month and a half since we finished the last clip of the video. Once you get the basic setup done, you can walk away and leave it for quite a while. You can work on it from weekend to weekend or whatever and not have too much trouble. Although I don't recommend leaving the drill out in the rain because it can eventually get a little bit rusty inside and won't run quite as well until it gets lubed up again. But I tested this last night. I made sure everything was working. I've got the oiler filled up. I've got everything hooked up to the pipe, air hose. Everything's running, ready to go. At this point, you want to stop, take stock of what you're going to do and what you're about to accomplish here. You need to make sure that everybody who's going to work on your project is familiar with how the drill works, and most importantly, that you never, ever, ever turn the drill off underwater. Because if you turn the drill off underwater, mud gets stuck down in the drill motor, and that means that you have to take the drill all apart, put it all back together, and that's quite a project. So to avoid that, make sure that never, ever happens. And everyone on the project needs to be very familiar with that rule. 90% of the people who send drills back to me because they're not working have broken that rule. So, as you may also have noticed, we have some geese since we got the last video started. So, the second major rule is that you always want to turn the drill on in the casing. The reason being is that that bit spins very fast, with a lot of pressure, and if you have any important body parts around it, it can eat them. It can grab a hold of clothes, loose pant legs, things like that. So you need to have that under control before you start it. So when you go to start the drill, you need to have it in your temporary casing like this before you turn it on. That way, when it starts spinning, it's going to be spinning down there and not someplace up here around other people. The third major rule is that you never, ever, ever leave the drill unattended. You don't care if the phone rings, someone shows up, house is on fire, never leave the drill alone. The reason for this is that you're down there drilling in a very dynamic environment. Stuff is moving, pressures are going down there and changing. You're drilling through pockets of sand, rocks, and things like that. At a moment's notice, a piece of that can collapse. And when it happens, it's going to be suspended in the water for a little while. If you imagine a big pile of sand being dropped in water, it's going to disperse until it gets to the bottom where it's going to settle. Now, if your drill is sitting there without being moved up and down constantly, then you're going to have that happen and trap your drill in a matter of a minute or less. I've had it happen. If you're there working on the drill, moving up and down like you're going to learn how to do in a minute, that's no big deal because you're moving up and down, and so it's going to keep stirring that mud and pumping it out. If you walk away for 5 minutes and you come back, you can easily come back and find your drill trapped. Now, there are ways of rescuing it when that happens, which we'll cover later in the video, but it's still something you want to avoid if at all possible. And you can avoid it by making sure that somebody is always there physically holding onto the drill at all times. Those first 3 rules always apply without exception. They always have to be followed. Never let them go for any reason. The next 3 are a little bit more flexible. Number 4 is keep the hole full of water at all times. You want it to be full of water within about 3 feet of the top. Now, this is preferable but not absolutely essential under certain circumstances. The reason being that the drill functions by pumping up water, by using the head of water that's in the hole to blow water out the top of the pipe. The more water you have in the hole, the deeper you are, the more water is above the drill, the more efficiently it's going to pump, like you just saw a minute ago. But when you get deeper, 70, 80 feet, having all that head is going to be really great because it's going to pump really well, even be able to pump thicker sludge. But it's going to be harder to keep the hole full of water as you go deeper, especially when you start out for the day, because it's going to take a lot of water to fill up that hole. Once you get deeper, especially once you're deeper than about 100 feet, and especially if you have a deep temporary casing in there, like say 50 or 100 feet of casing down, which I'll show you about later, not quite as essential that you keep the hole full of water. The other reason is that it helps to prevent cave-ins quite a bit. Cave-ins happen because you have a vacuum, because you've sucked out dirt and rock, and you have a hole of air in its place. So when you have a hole of air, dirt tends to fall in because the air weighs a whole lot less than the dirt. If you have water in there, that's better because the water weighs a lot less than the dirt, but it also weighs a lot more than air. And so you're going to minimize the cave-in problems. As you go deeper and you have 50 or 60 or 80 feet of water above your drill, that 80 foot of water puts an enormous amount of pressure on the bottom of the hole. And that pressure serves to keep the sand and the mud from coming into the well in the bottom, and it helps to deter cave-ins. So in almost all circumstances, the more water you keep in the hole, the better off you're going to be, and it's going to prevent cave-ins. But when you get to a certain point, it's going to find it's basically impossible. So do the best you can. Rule number 5 is, if you get to a position where it stops pumping, now you're not going to pump at the first 15 to 20 feet. But when you get down to 30 or 40 or 50 feet, you should be pumping very consistently. If you have the hole full of water like you're supposed to, you're not going to have moments of 2 or 3 minutes where nothing comes out the end of the pipe unless you've got a potential problem down there, like a clog or something too thick. So if it stops pumping, be concerned. Pay attention, move your drill up and down a bunch, see what happens. And that leads me to rule number 6, which is, if you have a question, pull it out. One of the major advantages this has over other well drilling systems on the market is that we can pull the well out, we can put a new bit on it, we can sharpen the bit, we can clean something, we can go back down the well, and we can do all of that in less than 5 minutes. Because it's just pipe hand over hand, check it, hand over hand back down, and it's really easy, as opposed to cranking up derricks with heavy metal pipe. So take advantage of that, and if you have a question, get that thing out of the hole, look at it, make sure the drill is turning, check on it, and if it's working, fine, go back down the well and just keep trying. If not, you'll have not wasted half a day stubbornly trying to do something when the drill wasn't even spinning, or when it has mud clogging up the housing. So, you've learned those basic rules, make sure everyone on the project is very familiar with them, and you'll avoid most of the headaches that happen with well drilling. One of the most common questions people ask me is, how do you keep the hole straight while you drill? Now, for years, people have drilled holes with this system without any help at all, and they come out mostly straight. And as long as you're only using thin-wall PVC pipe, that's fine, because thin-wall PVC pipe has the ability to follow the hole even if it weaves a fair amount. And the drill's not just going to go off on a random tangent down there. It's just going to mostly, average itself out when it makes mistakes, unless you have large rocks or things like that. However, I have recently developed a better way of doing it that will allow you to drill a very straight hole, which is necessary for 4-inch thick wall casing or for 6-inch casing, because neither one of those has very much flexibility in it, so the hole needs to be pretty straight. So for that, I've developed these spacers. Now the idea is, the drill just has a bit on the end of it, and the bit is a whole lot bigger than the pipe. And while the pipe is reasonably straight, it gives it a lot of latitude for the hole to be here, and the drill to go up as much as this, and thus allow the hole to wander a lot based on the bit. However, with these spacers, which as you can see are shaped kind of like a door handle, if you put these on the side of the drill like this, on 3 sides, this makes a roughly 6-inch size spacer, which is just slightly smaller than the bit itself, which means the bit drills the hole, and these are going to follow behind the bit and keep it in the middle of the hole so that this can't wind up going off like that. And this will make a big difference in how much your hole is straight. Now, if you're only going to 50 feet, if you're just doing a shallow well, thin wall pipe, or even